We are now going to have a look at SQL injection attacks. This is perhaps the single most dangerous vulnerability faced by web applications today. Even in 2020, a lot of the big companies are being hit by SQL injection attacks, and the consequences are devastating. So this leads to a compromise of the confidential information such as client usernames, passwords, their addresses, credit card information, which causes not only financial damage but also reputational damage. So sometimes the hackers they even release this confidential information on public forums. There's another more serious aspect, which is the introduction of recent privacy laws. So for example, the European Union has introduced GDPR, the Global Data Protection Directive. Under this directive, any company in the world which stores the personal identifiable information of EU citizens is required to take appropriate steps to ensure the safety and integrity of the data. And not taking those steps can result in fines and regulatory problems. So another reason why SQL injections are still active today is because a lot of the web applications they are built on SQL databases at the backend. Since it's a very popular technology, though we have hundreds of thousands of web applications which use the SQL database at the backend, and that's why SQL injections are still a serious concern today. So let's demystify SQL injections. We're going to see how SQL injections basically pierce through the web application and access the backend database to extract crucial information. So basically we have the web server which basically hosts the website and runs the web application. So this is the client facing part. But it also communicates with the database at the backend. Now the database is hidden behind a lot of firewalls and a lot of security apparatus. But eventually your web application obviously needs to access this database in order to get information, update information, and so on. So the database contains confidential information such as usernames, passwords, and other company proprietary data. Now the users they access the web server over the public internet. So let's say this is a website and this is a login page. So the user is supposed to enter his username and password, which he does. So let's say he enters Jack and 123 as the password. And here is the backend code for this website. So basically this is the website and this is the website code at the backend. So basically we have a variable called name, which basically stores whatever is input in the user field here. Similarly, we have a variable password, which gets whatever is entered in the password field here. And then based on this information which we get, we are going to construct an SQL query which says that select asterisk, which means everything, from the table users, where name is equal to something and password is equal to something. So the basic idea is that once the user has entered his username and password, these variables are passed on to here to construct the SQL query which is sent to the database. Now let's see how this works in action. So the username is sent here, and then it's passed on to the SQL query. So it becomes select asterisk from users where name is equal to Jack. So similarly, the password is captured by this variable and then passed on to the SQL query. So now this query is executed. This is sent to the database and it extracts the correct information. So the username is Jack and password is 123. And this is how information is passed onto the web application or to the front end of the website. Now this is the normal flow of a web application. Now let's see how SQL injections exploit this. We are now going to explore how an SQL injection works. We consider the exact same scenario. We have the same web server which communicates with the backend database, and the database has confidential information stored in it. So a malicious user accesses the website over the public internet. So here's the website. But now, instead of entering correct information in the username and password fields, the malicious attacker enters a crafted string, which basically renders an SQL injection in order to extract confidential information from the backend. So if we see the backend code for the same website, we see the same name variable and the same password variable. But now, the values of these variables would be different. So previously, our final query which was constructed was select asterisk from users where name is equal to Jack and password is equal to 123. But now we'll have a different query because the variable name and passwords are replaced with this string. So basically, our final query becomes select static from users where name is equal to blank or 1 is equal to 1 and password is equal to blank or 1 is equal to 1. Now please note that these quotes are inserted by the code itself. So the last quotes, both at the left side and the right side, are inserted by the code. So that's why when we craft our query, we always start it with a quote, which basically terminates the leftmost quote. And when we end our structured SQL injection, we basically introduce a quote here, which basically corresponds to this ending quote. We do this so that the SQL query is structured properly, because if there's an error in the syntax of the SQL query, the server is going to throw an error and the malicious user would not be able to extract the confidential information. Now, if you notice this query, the result of this query is always true because we have used the OR operator. So basically, if the name is blank, or 1 is equal to 1 and 1 is always equal to 1, so that's why the result is true. And then we use the AND operator and we say password is equal to blank or 1 is equal to 1. So once again, this statement is true. So as a consequence, when this statement is executed, the result is true and it matches each and every single entry of the database, and all of the fields in the database are extracted. So that's how the malicious hacker is able to extract all of the records in the database by structuring a query which exploits the structure of the SQL language. Let's take a closer look at the SQL injection. Now this was the correct format of the SQL query. Select static from users where name is equal to Jack and password is equal to 123. Now here's the malicious query. Select static from users where name is equal to blank or 1 is equal to 1 and password is equal to blank or 1 is equal to 1. Now if you notice, the leftmost quote and the rightmost quote are inserted by the code. So that's why when the malicious hacker introduces the SQL query, it always starts with an escape quote for the left quote and an opening quote for the terminating quote. So this is done so that the structure of the SQL query is intact. Similarly, for the password field, quotes are introduced so that the SQL query terminates correctly. We don't necessarily have to use 1 is equal to 1. Basically, we can use any condition which results in a true statement. So for instance, we could use blank is equal to blank as an alternate to 1 is equal to 1, because a blank is always equal to blank and blank is again always equal to blank. So basically, as long as you have the final result as true, then the query is going to extract all of the fields which correspond to this. Now since every single record in your database corresponds to true, that's why the malicious hacker is able to extract all of the confidential information from the backend. We can also insert the malicious SQL injection directly into the URL. This is different from what we just did. So basically, what we just did was insert malicious SQL queries into the input fields. But now we are going to explore how we could enter this information directly into the URLs. So we have a website of songs, and if you notice the URL, there is a question mark. Now this indicates that next would be a variable and its corresponding value. So we have the variable song ID with the value of 12. So when the final SQL query is rendered, it basically contains where song ID is equal to 12, and that's why we see song 12 being selected. Now let's see how we can insert a malicious SQL query within this URL. So the original SQL query was select static from songs where song ID is equal to 12, and this song ID variable came from here. So now we insert song ID is equal to -1, and then we maliciously introduce union operator and say select static from users. So what the union operator does is that it executes this part of the query separately, and then it creates a separate query for this part. So the final query becomes select static from songs where song ID is equal to -1. So this is not going to return any song because we don't have any song with an ID of -1, but that's okay. We are more interested in getting this thing. So union select static from users. So when this subquery gets executed, it's going to fetch each and every record from the users table. As the final results indicate, we don't have any song in the songs table, but we get each and every single record from the users table, because this statement is true for all of the users. So this is how you can insert SQL injection directly into the URL and fetch confidential information from the backend database. Now, SQL injection is quite dangerous because a lot of the technologies around the world, they use SQL databases at the backend along with PHP as the programming language. Now we have discussed two variations of the SQL injection attack. The first was when we inserted the SQL injection into the input fields, and secondly, when we inserted the SQL injection directly into the URL. There are a number of other variations of the SQL injection attack. However, the basic idea is still the same. The basic purpose is to craft a string. When inserted into the code, it renders an SQL query which basically fetches all of the confidential information hidden inside your database. Next, we're going to see another variation of the SQL injection attack, which is the blind SQL injection. Then we're also going to have a look at a couple of mitigation solutions on how to mitigate SQL injection attacks. I'll see you in the next lecture.